Hello everybody. So yeah, I decided to get started with a series of making a Battle Royale game in Unity for PC. I will show you everything I know on making a whole bunch of, or I'll show you everything I know about making a game. So yeah, well, first off, we're gonna need some ideas. So the game's name will be Bounty Edge. It's gonna be a Battle Royale. Um, First person. Sort of like a low, we're gonna need like a low poly sort of a thing. And yeah, free. So, let's get started. Inside of Unity Hub, we will make the project. Bounty Edge. Alright, so while that's getting started, what we're going to want to do is head over to Documents, Blender Projects. I do have this little dude, so you might recognize him from our other game that we have made. Oh, that's Blender 2.9. So you might recognize him from the VR game we made on itch.io with Unity. Player. Okay. Well then, open. Blender Projects. Player. Alright, player body. But yeah, you might recognize this dude. He's our little friend. And yes, wait for Unity. Okay. Now, I do have a few models for guns that I'm using for a separate project that got discontinued. Which this is actually a knife. We got health kit, explosive barrels, a whole bunch of stuff. And we're going to be using pure physics to make the player move. So this episode will be player movement. Now, we're going to make a new folder. I'm going to call this player, just to be organized. I will also make a new folder called lighting. Lighting will hold all the variables for lighting settings. I'll call this real time. Uncheck, check, lighting. Give it a few seconds, and bada bing. Oh. And of course, the bada boom. Okay. Now, let's get player movement down first. So we're going to use a tile texture that Unity has provided. I will make a new empty. I'll call this environment. This will house the directional light and the plane. Okay, so we'll make a new folder called materials. Now the materials folder will house all of the materials that we're going to be using for our game. So I'll call this tiles. I'll drag this onto here, and inside of albedo we'll use the tiles. Now I'll set that to not smooth at all. 5. No, sorry, wrong one. We're going to set that to 5 by 5. Okay, now I'm going to make a new game object, and I'm going to call him the player. Now, this player, we're going to give him a capsule glider. Alright, 1, and height is going to be 2. Okay, we're going to give him a layer of player, which is layer 8. So now we're also going to have a camera, offset 1.5, set the field of view to 90, and 0.01 for clipping planes. So that's going to be the camera. Inside of player, I'll make a new folder. It'll be called scripts. Inside of scripts, we're going to have the C# script called player movement. We're going to double click on that. And I'll tell you what I used to use for storing, or for movement. Now, I never use the character controller because it's way more limited than the rigid body, and also the rigid body is just overall better. So, yeah, we're gonna get the player movement onto script onto there, and yeah. So what I used to do is I used to have the velocity, or I used to have it so that it replaced the velocity, or I made a new variable called forward and right velocity, and that used to replace this velocity, which would basically ignore gravity, it would ignore physics, all that sort of stuff. So we're going to be doing add force. So we're going to open up Visual Studio. We're going to give it a second to load the project. And yeah, okay. So we're going to need some variables. Let's make a public rigid body called RB. We're going to need a public float. This is going to be move speed. I'll set that to about 1000. Terminal velocity. I'll set that to about maybe 4 or so. Yeah. Okay, so now let's make a few private variables. We'll make a vector2 player input just player input, and private vector3 player velocity. Alright, now we're gonna make a new private void movement. So we're gonna store that inside of the update function. So for the private void movement, what we need to do is player input equals new vector2, and this is going to be input dot get axes horizontal, and input dot get axes vertical. Okay. So now all we need to do is we can just copy this and do vector2 dot clamp magnitude and paste this back in and set that to 1. So this will basically make it so that if we go diagonal, we go the same speed, or we don't go faster diagonally. We just go same speed. We go the same speed for all directions. Now we need a vector3. I'm going to call this F movement. And it's going to be transform.forward times player input.y. Another vector3 right movement equals transform.right times player input.x. Now we're going to set player velocity to right movement or forward movement plus right movement. Now what we need to do is we need to add the force. So rigid body dot add force player velocity times, or actually hold it, we can do this. So over here we can multiply this, or no, we can actually just do this, move speed times speed, and then rigid body dot velocity equals vector3 dot clamp magnitude rigid body dot velocity to terminal velocity. And yeah, that should do that. So we're gonna give it a few seconds to compile, and then we're gonna set the rigid body to this, and we're gonna press play. So now if you notice, oh crap. So you can notice that I'm going way faster than what I should be going. So I'll set that to about 100. So yeah, if you look at the information, you can see that it maxes out at 4. We can set that to 2 or anything lower if we really wanted to. So 100 and 2 seem like good values. Yeah, 102. Alright. I'll set this to interpolate and continuous dynamic really quick. And yeah, so what we can also do is we can also have a vector 3 gravity. We're set that to transform, or no, vector 3 dot down times gravity scale. I'll set that to about maybe like 10, and we can add gravity scale to that. Or not gravity scale, gravity. This probably might screw some things up, but who knows. Okay, here's what I'm gonna do. I'll make another bigger platform. Right underneath it, I will duplicate this, call this tiles, _1, and tiles 1. So this is gonna be 10 by 10, 50, 50. And also I'll just do this so then we can see that. I mean, it kind of works. So what we can do is gravity scale. Let's set that to about 21. We can keep on increasing the values to see how it works. Okay, so if we change the mass to a higher value, then the speed gets screwed up like this. Alright. Okay. Now here's the problem here. Here's the problem. Hold up. No, we have to clamp that. So here's what I'm gonna do. We're gonna put void gravity. So void gravity, and vector 3 equals vector 3 dot down times gravity scale, and then rigid body dot add force gravity s. Alright. Now hopefully we should get acceptable results from this. So kind of. I mean, here, let's look at the info tab on the speed. You can see that it clamps out at about 2. Okay. We can set it back to 1. What if we set it to about maybe like 50? And then I have another way of setting up. Yeah, that works better. So here, really quickly, let's set this stuff up. So player, Omni Games, okay. Then inside of time, we can set this to 10 divided by 90, which is I've been using this physics value for a while, and it's overall seemed to give me some of the best results. Okay. Here's what I'm going to do. I'm going to make a new empty called ground check, and I'm going to make a public transform called ground check lock, and then ground check rod 0.05f private void ground check. Alright, with ground check we need to do this. So we need a collider. I'm going to call this calls. We're going to set this to physics dot overlap sphere, and this is going to be ground check lock dot position ground check rot, and we're going to make a new public bool is grounded. So we're going to set is grounded to calls 0 does not equal null, and calls 0 dot gameObject dot layer does not equal player layer. And I'll make that integer in a minute. Alright, public int player layer equals 8. So with that, what we're going to do is, inside of gravity, I'll make a float, or a private float, OG gravity scale. So, OG gravity scale, so if is grounded, or if we're not grounded, then we're going to do gravity scale plus equals time, or we're going to do OG gravity scale times time dot delta time, and if is grounded, gravity scale equals OG gravity scale. Alright. Hopefully this works, so we'll drag this into here. So now you can see everything's working, and then, alright. I'm gonna do this really quick. So player velocity equals clamp magnitude. If is grounded. No, if is grounded, sorry. Okay. Now I'm gonna set the gravity scale down to like, what, maybe like 10? Okay. So now, whoa. Alright, what we're gonna do now is I'm gonna do this. Alright, now well, why don't we just clamp that? Well, no, hold up, then we can't have air control. We want air control, like the tiniest bit. But here's what's happening. Oh, wait a minute. Hold up. So it was still adding player velocity force. So what if we do this now? There we go. Well, now we don't have air control, but whatever. It works. Okay. So let's make jumping, which is everybody's favorite thing. So private void jump. So what we're going to do is, actually I'm going to make player input a vector 3. Actually no, we can just do this. So I can pop that right over there, and bam. Okay. Equals vector 3. New vector 3. What we can do is we can have this input dot get axes jump. Input dot get axes vertical. Okay. So now input dot z. So if input dot, or no, if player input dot get axes, or no, dot y is greater than 0, and we're grounded, rigid body dot add force vector 3 dot up times jump force, and Jump force. Let's throw this into here. Okay, just thought of a issue. So it's gonna just simply snap the value. Jump force. Alright, I'll set that to about 10. Set that to about 50. Okay, I'll set that to about maybe 100. Alright, maybe like 500. Okay, here's the thing. So, I'm gonna set this really quickly. Force mode dot impulse using its mass. Okay, so this uses its mass. Now what we can do is we can try to do like a complete velocity change. Okay. Oh, no, wrong variable. Whoa, shit. So you can notice that. And also when we jump. Okay, that's perfect. It doesn't go through walls and everything. Okay. Hold really quickly. Let me see this. 21 minutes now. Okay. Yeah, we're learning together, my friends. Now, what if we do force mode dot velocity change? So we just completely change the velocity no matter what. So now let's set this to about 7. Well, here's the problem now. If we hold it, we jump higher. We want to make it so that it's just, you can see if we're not moving compared to if we're moving. Which is kind of insane. Alright, well, let's see. What about acceleration? You can see that we're having some issues with that. Okay. Now here's another thing that we can do. We can do rb dot. We can just do rb dot add force, vector 3 force. This is all we want to do, but we're having a ton of things that are limiting us. You see that we can jump higher, depending on when we press the button, which is not necessarily what we want. What we can do is we can have like an animation curve that does that, or that does that. Is grounded. Let's see. Here, I'll pause the recording until I can come back to it really quickly. Let me see what button it was. Hotkeys. Alright, well, Alright, I'll come back when I find a solution. Crap, that's not working. Alright, well, I'll be back when I find a solution.